Today we're going to be answering an FRQ from 2003, question number 1. And in this problem, we are given the function y equals square root of x and y equals e to the negative 3x, and the vertical line x is equal to 1. And also, the area under the curve or between curves are also given. So let's go ahead and write down our function. So we have y equals square root of x and y equals e to the negative 3 to the x. We also have the vertical line at x equal to 1. So we are supposed to answer letter A, and in A we need to find the area of the region R. So let's go ahead and use our calculator and plug in the values of the given function to our y sub 1 and y sub 2. Y sub 1 is square root of x. Y sub 2 is e to the negative 3x. So I will label this as y sub 1 and this as y sub 2. So the first question is to find the area of the region R, and we know that the function, if we're going to draw it, the function square root of x and the function e to the negative 3x and x equal to 1, and this is R, or region R, that we're trying to solve. And we know that the formula for finding the area between two functions or between curves is going to be the integral of your top function minus your bottom function, and here we are going to integrate with respect to x from a up until b. Now we know that the upper limit will be at 1. We just need to figure out the lower limit, and to do that we're just going to equate square root of x and e to the negative 3x, or use our calculator to find the point of intersection of the curve. So since we all have the function already, if we graph this, let's zoom it in. And this is the graph of our function, and we're going to find the point of intersection of function 1 and function 2 to find our lower limit for our integral. So we have the graph, second function, trace, go to intersect. So this is your first curve, and this is your second curve. And the point of intersection that we have here, let's call it t, and t is equal to 0.2387. 0.23, let's round it up to 0.239. So this is our value of the point of intersection of our function. So now we know that we're going to integrate this function from t to 1, which is 0.239. So the area is equal to t up until 1, integral of the top function, which is square root of x, minus the bottom function, which is e to the negative 3x dx. And using our calculator, math 9, t is 0.239 all the way to 1. And we know that our square root of x is y sub 1 in our calculator. So vars, y sub 1 minus y sub 2 dx. And it will give us the value of the area between the two functions, and it's giving us 0.44262. So let's round it up to 0.443 unit squared. So this is the area of the bounded region, and this is our answer for letter A. For letter B, we're supposed to find the volume of the solid generated when R is revolved about the horizontal line y is equal to 1. So for letter B, we need to find the volume of R. And to illustrate the volume, here is our graph. 1. This is y sub 1. And this is y sub 2. And it's from t up until 1. And in this case, our R is revolved about the horizontal line y is equal to 1. So this is y equals 1. And it's being revolved around y is equal to 1. So if this is R, we know that we have a solid with a hole in the middle. So this one is finding the volume of a ring, which is given by the formula pi from A to B of the bigger radius squared minus the smaller radius squared. And we're going to evaluate it in terms of x. So first, we need to find the value of the bigger radius. And the bigger radius is from the bottom of the function all the way here. So here, big R, top function of big R minus the bottom function of big R. The big R has a top function of y equals 1 minus the bottom function, which is y sub 2, and y sub 2 is e to the negative 3x. So this is now the function for our big R, which we are going to use in the formula for the volume in a little while. Now, for the small letter r is represented by the top minus bottom of the smaller radius of your ring. So you have top minus bottom as well. So small r is y equals 1 minus the bottom function, which is square root of x. So now that we have our big R and our small r, let's go ahead and plug in all the values in our integral function. So the volume of R is pi times A, which we know is 2.39, and upper limit of 1. The big R is 1 minus e to the negative 3x squared minus the small letter r, which is 1 minus square root of x squared evaluated with respect to x. So this is our integral function, and using our calculator, so we have pi, math 9, lower limit is t, which is 2.39 or 0.239, upper limit of 1. The first function is 1 minus e to the negative 3x squared, so I'm going to put in quantity 1 minus my e to the negative 3x is y sub 2, and I will raise it to the second power minus the second group, which is 1 minus the square root of x, which is y sub 1. Close it and raise it to 2. dx. And the volume of this region revolved around y equals 1 will be equal to 1.424 unit cubed. And this is problem letter B. For problem letter C, the region R is the base of a solid, and for this solid, each cross-section is perpendicular to the x-axis, which is a rectangle whose height is 5 times the length of its base in region R. So let's find the volume of this solid. So let's illustrate the graph once again so we can visualize what we're trying to solve here. This is our square root function, y sub 1. And this is our exponential function, y sub 2. This is 1. And this is t. And according to this problem, the base of the solid R, which is this, the x-axis or the cross-section is perpendicular to the x-axis, which is a rectangle, and whose base is 5 times the length. So first we're going to find the formula for finding the volume of this solid. So we're going to have the volume of this solid whose base is 5 times and it's evaluated from t to 1 dx. Now the question now is, what will be the equation or the function for our base? And the base, according to this problem, is a rectangle, and we know that a rectangle, the area of the rectangle is length times width. So in this case, we have just one base right here, which is top minus bottom, and we're just going to square it. So this will be the area of the rectangular cross section that we're using in this problem. So we have top function is going to be y sub 1, which is square root of x, minus the bottom function, which is e to the negative 3x. And we're going to square it because this is representing the cross section of a rectangle. Now, to evaluate the volume of our figure, it's going to be evaluated from t, which is 0.239 up until 1, and the base, which is square root of x minus e to the negative 3x squared. And according to the problem, its length is 5 times, or 5 times the length of the base. So we're going to multiply this by 5. So using our calculator, let's find the volume of this solid figure. So let's have math 9 from 0.239 to 1 of the square of y sub 1 minus y sub 2, and let's square it, and multiply it with 5. dx. And our calculator is giving us 1.554. So the volume of this cross section will be 1.554 unit. And this is how we solve the 2003 FRQ from Calculus AP.